What if you could leap into the future, or return to the past to undo a regret, fix a mistake, or just witness history unfold? Time travel. A concept that has dazzled scientists, fueled sci-fi blockbusters, and sparked endless debates. But is it just fantasy, or could it actually be real? In this video, we'll explore the science, the paradoxes, and the mind-bending theories that might one day make time travel possible, or prove it's forever out of reach. Stay till the end for the most bizarre solution that might allow. Chapter 1. The science behind time travel. Let's begin with what we know. Einstein's theory of relativity. According to Einstein, time is not fixed. It stretches and compresses depending on how fast you move. This is called time dilation, and it's not just theory. It's been tested using atomic clocks on high-speed jets and satellites. In the famous twin paradox, one twin travels at nearly the speed of light, while the other stays on Earth. When the traveler returns, they're younger than their sibling. So, yes, traveling into the future is theoretically possible. But what about the past? That's where things get weird. Chapter 2. Faster than light travel and closed time-like curves. Einstein's equations suggest that if you could travel faster than light, time might actually reverse. But there's a catch. Doing that would require infinite energy, which we can't produce. So, does that slam the door shut on time travel? Maybe not. Enter closed time-like curves, or CTCs. These are theoretical paths through spacetime that loop back on themselves, like a cosmic racetrack through time. If CTCs exist, you could travel into your own past without going faster than light. Rotating black holes and Gödel's spinning universe are two examples that might contain these loops. Sounds promising. But here's the kicker. There's no experimental evidence for any of this, yet. Chapter 3. Grandfather paradox and logical nightmares. Even if we could travel to the past, we run into one massive problem: paradoxes. The most famous? The grandfather paradox. If you go back in time, and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, how did you go back in time? Other paradoxes follow the same pattern. Stop a disaster from happening? Then why did you go back in time in the first place? These contradictions might mean changing the past is impossible. Novikov's self-consistency principle. Russian physicist Igor Novikov proposed a clever solution. If time travel is real, then the universe prevents paradoxes. That's the Novikov self-consistency principle. You can go back in time, but you can't change anything that would create a contradiction. Try to kill your grandfather? You can't. Try to stop a disaster? Something else causes it anyway. It's like fate course corrects itself, ensuring that everything remains consistent. Chapter 5. Why haven't we met time travelers? If time travel is possible, where are all the time travelers? Here are a few theories. They're hiding. Their presence might be subtle, or they're forbidden from interfering. Parallel universes. The many worlds interpretation says going back creates a new timeline. So they did time travel, just not in our universe. Technological limits. Maybe time travel only works back to when the machine was created. So until we invent it, no one can show up. Chapter 6. Physics dilemmas, mass, energy, and entropy. Time travel also challenges core laws of physics. Would meeting your past self double your mass in the universe? Not necessarily. If the time loop is a closed system, then no mass or energy is created, just redistributed. But there's another issue: entropy. The second law of thermodynamics says, entropy, the universe's disorder, must always increase. Traveling to the past means decreasing entropy, which violates this law. Unless. Chapter 7. Quantum mechanics and stable loops. Quantum mechanics offers a loophole, literally. In most physical systems, quantum fluctuations, small, random changes in energy, are unpredictable. However, in a time loop where events repeat infinitely, randomness might actually disappear, allowing only self-consistent states to persist. This could mean that in a time loop, the system stabilizes in a way that allows for consistent time travel without contradicting physical laws. Chapter 8. Does the universe balance the books? Some scientists believe that any entropy lost in a time loop is compensated elsewhere in the universe. Maybe the loop behaves like a black hole's event horizon, where information isn't destroyed, just hidden or redistributed. If true, time travel might not break the universe after all. It might just bend it. So, will time travel ever be possible? We don't know, but the math says maybe. Time dilation, closed time-like curves, quantum mechanics, they all hint at strange possibilities. But without hard evidence, it remains speculative. Still, one thing is certain: the laws of the universe are far weirder than we ever imagined. And perhaps, somewhere out there, in a loop we haven't noticed yet, time travelers are already watching this video, before it was even made.